Hey folks, I'm Mr. Hartzler, and I want to talk to you about solutions by addition. I've never heard it called that though. For some reason, this textbook is, but solving by elimination, that's all we're really doing here. And it's not as bad as what some people make it out to be. This first example is going to be really easy, but then the next one is actually a little bit more realistic. So first off, I'm checking everything out. Looks like everything's kind of in order. I like having my x's on top of x's, y's on top of y's, and so on. And if I look at this too, I have positive 2y and I have negative 2y. If I add those two things up, they're going to cancel as is. So I'm just going to add up this top equation with this bottom equation, and we'll see what we get here. X plus x gets me 2x. 2y plus a negative 2y gets me 0 y's. And I don't even have to write that, so I'm not going to. Sometimes that confuses people. Then I have a negative 7 plus a positive 1. That gets me a negative 6. 0 plus 0 is still 0, and my equal sign is going to come down just like normal there. Now I need to solve for x still. So I'm going to add 6 over. So 2x equals 6. Now I have to divide by 2 so that I can get my x by itself, and then x equals 3. But I'm not quite done yet. Solving a system, right? These have x's and y's. I only have my x. I still need to find my y. And I can plug it into any of these I want, and I'm going to choose my second one just for the reason that there's smaller numbers in there. So I plug that x in. So it used to be x minus 2y plus 1 equals 0. Instead of an x, though, I'm putting that 3 in there. So now it's a 3 minus 2y plus 1 equals 0. And what is 3 plus 1? Well, that's 4. And then my 2y is still hanging out there. I need to solve for my 2y, so I'm actually going to add my 2y over. So now 4 equals 2y. Divide by 2, and y equals 2. I would not accept this for my classes, but for a lot of people it's fine. But you should set this up like a coordinate point, right? 3, 2. Solving a system, right? Both of these are lines. They cross at the coordinate point 3, 2. That's the important part here. Let's go and check out our next one. All right, so still x's, y's, and numbers are all kind of set up on top of each other. I like that. But if I add my x's up, I get 3 x's. If I add my y's up, I get 2 y's. I don't like that. That's going to make things tricky for me. So I need to instead try and get some of these, either my x's or my y's, so the numbers on front are going to be the same, but opposite, right? So if I had a 2x on top, I would like a negative 2x on bottom. And let's actually do that. If this were a negative 2, then those things would cancel. That would be awesome. How do I make that happen? Well, I need to multiply that entire second equation by a negative 2. And when I do that, I now have a negative 2x, and I'm distributing that to all of those pieces. So each of those gets multiplied by a negative 2. So negative 4y times negative 2 gets me positive 8y. Negative 9 times a negative 2 gets me a positive 18. 0 times negative 2, still 0. I'm going to do nothing to that top equation. I'm going to leave it exactly as it is. So I'm just going to copy it down over here. Now, let's add straight down. What is 2x plus a negative 2x? 0 x's. And like we discussed last time, I don't have to write that down. 6y plus 8y gets me 14 y's. 3 plus 18 gets me 21 equals 0. That's an ugly 21. Let's rewrite that. Boom. All right. Now I need to solve for my y. So I'm going to subtract 21. 14y equals negative 21. And I divide by 14. So now y equals negative 21 over 14. But I can reduce this. You'll notice 21 and 14, both of them, I can divide by 7. Real nice and easy. Negative 21 divided by 7 gives me a negative 3. 14 divided by 7 gets me 2. So I know that my y is negative 3 halves. Don't let that fraction scare you. It's not a terrible fraction. It's actually going to get cleaned up relatively easily. So I need to still find my x. So that means I need to plug this in to y. Which equation do you want to choose? I'm choosing my second one again, only because the numbers in front of x and y are smaller. You could use either one of these, though. It doesn't matter. All right, so x minus 4y minus 9 equals 0. That's what I'm using. Plug this y in right there. So it's x minus 4 times negative 3 over 2. Then I still have to subtract my 9, just like normal. All right, I needed to multiply these two things. So now it's x, two negatives, make a positive. So now positive 4 times 3 is 12. Still have to divide by the 2. When I multiply fractions, remember I go straight across, so 4 times 3 and 1 times 2. Or you could type that into a calculator. And 12 divided by 2 gets me 6. And 6 minus 9 there is a negative 3. So I have to solve for x, so I have to add 3 over. Look at that. Not as bad as you might have thought. And then I have to set up like a coordinate point. 3 comma negative 3 halves. I know it looks like a lot, but over on the right, we got it so that our x's were going to cancel, right? So now there's 0 x's here. Awesome. Then for the rest of that, we pretty much just solved for a remaining variable, which for us was y. Then we substituted that negative 3 halves for y in for y. Then solved for x. Okay, so we solved for y, then we solved for x. And that was pretty much it. Let's keep going though right here. Ooh, solving this one. All right. So the shortcut for all of these is on the next slide. All right, you're almost there. Go check that out if you're interested or if this is blowing your mind. Here, I would actually prefer to use substitution. But if we had to use elimination, then I'm going to get both of these equations to look more similar. So you see how the top one, everything's off to the left and it equals 0? We'll do the same thing on the right, or on the bottom equation. So I'm going to add x. So now it's x plus y equals 6. But remember on the top one, there's nothing on the right. It's just 0, so I have to subtract 6 as well. So now I have x plus y minus 6 equals 0. So I'm going to rewrite that up top. My new equation up there is x plus y minus 6 equals 0. And then that top equation, not changing anything, leaving it naked. Boom, right there. Okay. Now, if I were to check these, right, they're all in the right order. I like that. Negative 2x plus x, I get it, negative x. Y plus y, get 2 y's. And it doesn't matter about my numbers yet. So if I want something to cancel, I want these y's to cancel. That means I need this y to be a negative. How do I make that happen? Well, I have to multiply this entire second equation by a negative 1. That's going to give me negative x minus y plus 6 equals 0. I'm going to leave my top equation naked again, not changing any part of it. And it looks like this. Now I can add them up. Negative 2x minus x, negative 3x. Y minus y, nothing. Negative 6 plus 6, nothing. So it just equals 0. Divide by my negative 3. X equals 0. That's so cool. I love it when that happens. Now I need to take that and plug it into one of these. Which one do you choose? This one. Because look at it. Once I plug in that 0, everything's going to be real easy. So y equals negative x plus 6. But I know x is 0. So y equals negative 0 plus 6. 0 plus 6 is going to be 6. Boom. I know my x. I know my y. So it's a 0, comma 6. Now, this is the shortcut. Isn't that way better? I literally typed all of this into Desmos.com. Top equation, bottom equation. Oh, actually, I switched them, I guess. But that part doesn't matter, right? I typed the bottom equation in first, then the top equation. Doesn't even matter. See where they cross? Boom, they cross right there. I click on that. It was a gray dot. When you click on it, it changes color sometimes. And then it tells you 0, comma 6. Let's go back. Oh, wait. We got 0, comma 6. No way. But Desmos does it way faster. Do it the Desmos way, if at all possible, folks. Though I know some people don't allow you to use calculators. But if you can, use it to your advantage. See where they cross? That's your solution. Alrighty, folks. Hope this was helpful. And this was the addition method or elimination. Have a great day, everybody.